In this video, we'll look at the binomial distribution and specifically at how to use the binomial probability tables that are in the appendix in your textbook. So if you recall, a binomial experiment is one where there's a fixed number of trials. So n is the number of trials. We're repeating something over and over again. And we're counting the number of successes. So we define a success as something. And p is the probability of success on a given trial. So if we count the number of successes in n trials, then r here is a binomial. And so here at the bottom we have the formula where we can plug this into our calculator and calculate these probabilities. Although you can see this is a very tedious and kind of cumbersome formula to use. Now some calculators have this function built in. Another way is to utilize the tables. So let's start by looking at an example. Suppose that 40% of men wear glasses, so according to some poll. So if we take a group of 10 men and we start counting how many of them wear glasses. So if r is the number in this group of 10 that wear glasses, then this is a binomial random variable when n is 10 and p is 0.4. So p is the probability of success. So a success is whatever we're counting. So in this case, we're counting the number who wear glasses. So a success is a person who wears glasses. So p is 40%. So suppose we ask some probabilities. What's the probability that 2 of these 10 men wear glasses? Or 7 of these 10 men wear glasses? Or a group, fewer than 6 of these men wear glasses? So rather than use the formula, let's go to our binomial table. So if you go to your textbook and down to the appendices, there's a link for tables, and we're specifically going to look at the binomial probability distribution, which gives us the probabilities for a binomial random variable. So if we go back to our example, here's what the table looks like. So notice across the top are various values of p, 0.01, 0.05, 0.1, etc. And now this table keeps going, 0.55, 0.6, 0.65, all the way out to 95 and 99%. Then down the left side is your n value. And so this is just a portion of the table. It has n equals 1, 2, 3, 4, up to 10, and it continues on. So if you know your n value and your p value, you can look up these probabilities in the table. So here we look at p equals 0.4 and n equals 10. So if I wanted to find the probability r equals 2, I go over to 40%, down to n equals 10, and now I look at r equals 2. So notice across the table for r equals 2 under 40% is 0.121, or about a 12% chance that 2 of 10 men in this group would be wearing glasses. Similarly, if I look at 7, down to r equals 7 across to 40%, about 0.042. Okay? So you can calculate these probabilities without using that formula. Now the last one, we had the same situation, n is 10, p is 40%. But now it said, what's the probability that fewer than 6? So if you think fewer than 6, that would be 5 or 4 or 3 or 2 or 1 or 0. So you can see here, if we were using the probability formula, I'd have to figure out the probability of 5, then the probability of 4, the probability of 3, etc., over and over and add all those up. Or I can look at the table and look and say, okay, under 40% and n equals 10, I can add up 5, 4, 3, 2, 1, those probabilities. So there's about an 83% chance that fewer than 6 of those 10 men in my sample would be wearing glasses. Now, these tables are provided for n values up to, I think, about 25 or 30 and various p values. And so you can utilize these to find binomial probabilities.